Afternoon, everybody. Today we are discussing the next topic, molecular receptors in supramolecular chemistry. Molecular receptors are the chemical structures which bind to the receptors. The receptors may be cation, anion, or the neutral molecule. So the molecular receptors can be of any system such as crown ether, cryptand, cavitand, Calixarenes, or pollen. So the molecular receptors are the host molecule that containing a binding site or a cavity for a smaller guest molecule or an anion, and there is a weak interaction existing between the crown ether and the cation, and the molecular receptors form guest host complex which are reversible nature, and the molecular receptors are used for the separation, transportation, and sensing of the guest species. Now we are moving into the individual molecular receptors. First one is the crown ether. As we discussed earlier, the crown ether are the cyclic chemical compound that consisting of a ring of ether group. And the crown ether has a geometry of the crown which is used, so that's why the name indicate crown ether, and the oxygen atom are coordinate with the cation, so the exterior of the crown ether is hydrophobic in nature, and crown ether strongly binds certain cation and forming the complexes. The resulting cation form the salt that are soluble in non-polar solvents. So the crown ether used for phase transfer catalyst. An example for the crown ether is 18 crown 6 has a high affinity for the potassium cation, and 15 crown 5 for the sodium cation, and 12 crown 4 for the lithium cation, and the size of the crown ether determine the selectivity of the cation. These are the sum of the cation lithium, sodium, potassium, and cesium, and this is the size of the cation, and the second column represent the size of the crown ether and which can trap the cation. Now the next molecular receptors is the cryptand. Cryptand are the family of a synthetic bicyclic and polycyclic multidentate ligand for a variety of the cation, and this ligand bind the substrate in a crypt. That means the cation is in the interior guest, as in the case of a barrier, and the three-dimensional this cryptand is a three-dimensional analogy of a crown ether, and there are some selective and strong as complexes for the guest ion, and the complexes are lyophilic in nature, and the cryptand has a three-dimensional interior cavity, and the cryptand bind the guest ion using both the nitrogen and the oxygen donor, and the cryptand form a complex with many hard cation including ammonia, lanthanoid, and alkali metals and alkaline earth metal, and this is the structure of the cryptand, and in which the lithium is binded with both the nitrogen and the oxygen, and sometime in another cryptand one of the nitrogen, only one of the nitrogen is binded to the lithium, and oxygen is also used for the binding. Next is the cavitand. Cavitand is a container shaped molecular receptors, and here the guest molecule of a complementary shape, complex shape, and size, and the bridging. So this is the structure of the cavitand, and this is the structure which is shown in the right hand side is the guest host relationship of the metal and the cavitand, and the right hand side shows the cavitand which is formed by the resorcinol and bridging adjacent to the phenolic unit. Now next molecular receptor is the Calixarene. Calixarene is a monocycle or a cyclic oligomers based on hydroxyalkylation product of phenol and an aldehyde. So the molecule resembles just like a vase. So the Calixarene also form a complex with cadmium, lead and lanthanide and actinide. So it is used in commercial application for the separation or for the measurement of the sodium level in the blood vessels. So these are the some of the molecular receptors which is used in the supramolecular chemistry. And the Calixarene has a vase-like structures. Cavitand has a container-like structures, and the Cryptand has a burial-like structures. That is crypt-like structure substrate, and crown ether is just like a crown-like structures. Thank you.